Hey, morning, folks. Mm, 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 mm. Let's do the taking a break pre-stream. All right, I'll see you in a minute. Hey folks, hey, hello, morning. For your entertainment, I screenshot a photo. I'm gonna send it to me. Screenshot a photo. I wanted to find a farmer photo because I used to wear a hat, a Panama hat, a while ago. I was traveling a bit, and I can't find photos of it. I had to find an old photo that's not really good. There could have been better ones, but poo. Is there any? No. Strange. There's a lot of photos of me assembling an egg. What do you call when you warm up the eggs? You keep them nice and warm. This I found. June. All right, view, extra large icons. No. Some cool videos though. What the fuck was happening? All right. Wow. Cool, folks. Cool. Let me just go on Instagram. Excuse me, on WhatsApp. Very different applications, and we'll see if we can fit it in. Do 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 do. Do 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 do. Do 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 do. Do 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 do. Save image as. Yeah, sure. Save it here. We're gonna edit it. Oh wow, I thought I was gonna start earlier, but turns out we're not. Ooh la la. How do we crop things? Do we need to put it on Word or something? Copy Word. God, folks, Microsoft lacks so many tools, native tools. I feel it's like, ugh. The quick hydrate, quick drink something. Morning XR. Starting off with the I didn't hydrate actually. Jim the Dandy, Windows Shift S for snipping tool. Thank you. Yeah. Thank you, Jim the Dandy, and welcome. Good to see you. Good morning. We're still farming, everyone. We're still farming. All right, I just want to do one thing. Crop. And you folks are going to see the setup of it. Droop. I'm going to flip the image, actually. How do I flip an image? Right. Change picture. Search. Flip. Rotate object. Nice. Flip horizontal. There we go. All right, this is going to work. All right, save image as. All right, can I bring it in now? Or your folks are going to be impressed. It's going to be ridiculous. Pictures, download. All right, let's see if I can drag it in. Oh, yes, I can. All right, your folks are seeing it. It's Farmer, your cyber doctor. It's the most farmer image I found. It looks like a war picture. Windows Shift S for snipping tool. Yes, sir. Thank you very much. All right. We are back to farming, folks. I was thinking, do we want to take a little break and stop farming? I'm like, nah, it's okay. Take a little break. What for? Farming's the best thing ever. It was a really good recommendation, Jim. So let's go. The farmer was replaced. Vamos. The doctor is returning from the stream wars. Wow. Yeah, pretty much. All right. Look at this beautiful, beautiful farm. Pumpkin. All right. Can we grow? Oh yeah, we can. We can snap out of it. Nice. Woof. All right. Then we still kind of need to see the code and everything. All right. So, folks, so many things need to be done. There's pumpkin farming. We have a lot of water. We have a lot of fertilizers. But fertilizers are kind of a pain in the butt. There's a lot of things we can do now. Oh, I kind of forgot, though. Okay, let's see carrot and tree setup. We have a bit of both. Let's just remind ourselves how it works. Yep, this one does this. So you get all... You get... Wow, this is the perfect setup for trees. Trees love this. And I think now we can set up, depending on the resource that we need, we can all... Ooh, are you hearing this? I'm not hearing it. Very little. Do we want to get the sound today? I think I'm okay without it, actually. Okay, so we have this one that produces a lot of wood and stuff. A lot of wood, a lot of carrot. And to be honest, we don't have the need for water right now, I think. I can hear the thoughts in my head. It sounds like static. Oh my god. So much drama. Ooh. Hear the thoughts in my head. It sounds like static. Damn, XR. Alright, here's what we can do to make it even better. Yesterday, I think XR, you were no longer here if I remember correctly. Jim the Dandy was there, and we set up a farm, a plant, a powerhouse. Excuse me. All right, resetting. This is the official reset. We are gonna create sunflowers, and sunflowers XR, because I think you weren't there, are the powerhouse of our drone. So let's look at it. We unlocked it here. Sunflowers. Plant entity sunflowers. So sunflower and power. So when you harvest sunflower, you get power. And there's a condition that you have to follow to get power. The mitochondria is the powerhouse of the cell. Yes. Damn, I remember this. I went to US school and they kept on saying this too. I don't know what it means, but surely if people are interested by it, must be kind of interesting. I guess, no? Are you doing anything with this knowledge nowadays, Jim? Oh, nice. Close the door nicely. It's not, but hey, people say it. Yeah, right? It's not very useful anymore. All right, sunflowers. So sunflowers connect the power from the sun. Harvesting them will give you items that power. So we're going to unlock a new item. Base growth time between 5.6 and 8.4 seconds. Can grow on soil. Plant costs 1 carrot. Man, a lot of things cost carrot. Carrot is a pretty big base ingredient for other things. So, more seed sunflowers. Okay. So, we're going to I want to do sunflower. Sunflowers is, we need at least 10 flowers. I don't think there's a need to have more of them. So I suggest, and sometimes we need 6 by 6. 1, 2, 3. So, folks, if we want to farm a lot of things, pumpkins is optimized when we do 6 by 6. Because that's the maximum, that's when we get the maximum yield for massive pumpkins. Right? Just go back to pumpkins, I'll show you what I mean by that. Pumpkins. All right, let's see. N pumpkin yields n times 6. For n is superior or equal to 6. So actually you do get more pumpkins, no? It's a good idea to get at least 6 by 6 pumpkin to get a full multiplier. So yeah, we're gonna limit to 6 at the moment, the pumpkin farming. So if we count here, 1, 2, 3, 4, 5, 6. Right, that's 6 by 6 would be here. Wow, that's a lot of our garden. So I suggest the top left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or how many do we need minimum? Because there's a minimum number for power sunflowers. You need to have at least 10 sunflowers. All right, at least 10 sunflowers. All right, so let's see. 1, 2, 3, 4, 5, 6, 7, 8. All right, yeah, 8. That's just what I said, no? No, 10. I already forgot what I said. Okay, folks. Oh, we have a few more people. All right. Scott O'Brien, welcome back. Game logic. Plant carrot, get some flowers. If I am going to plant carrots and get something else, I better get a full cheese pizza. I mean, right? Hey, we don't know what the game offers later on. Maybe there's a full cheese pizza coming up. That'd be cool. I'd love that. Maya suggests you take the pumpkin size 7 times 7. This size also aligns with the rule around polyculture. Ooh, nice. Okay, so 1, 2, 3, 4, 5, 6, 7. Holy moly, that's like my whole board, Jim. And in order to get a bigger board, I think I need a more advanced crop. I need 4K carrots for twice the pumpkins. I'm down. More tree, yes please. Bushes for grass yield. Okay, wow. We're getting big. All right, so cool. We got a few more things. What do we want to check? Or sometimes, okay, we wanted to check how big a growing could be. So it's 8K. It's actually be doable. Huh? We can just farm pumpkins for a little bit. We can do it. All right, pumpkin farming. Let's go. Okay, you're not farming the right thing here. Pumpkin farming. Let's see it. Plant a pumpkin. Yeah, I didn't get this objective yesterday. I don't know why. All right, let's see if we can get a massive pumpkin here. Doot, doot. Doot, doot, doot. All right, should be able to, no? Oh no, one's bad. Oh no, it started harvesting. No, don't do that. Oh no. Oh no. Ay, ay, ay. All right, at least we got a bigger one, but yeah. Ay, ay, ay. No, 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 no. For one pumpkin, we're one pumpkin away. Nope. I think we're gonna start collecting here. Oh no? Oh no? I think you should collect. Yes. Farm 10,000 pumpkins. Okay. I'm like cheering on this. I'm like looking at this. Can you unlock polyculture? Yeah, good question. All right, polyculture. Polyculture, my good sir. Mazes, cacti, polyculture. 3K. Use a combination of plant type XY, get companion. All right, Jim Danny, we trust you. You have already noticed that sometimes plants yield more when planted together. Grass, bushes, tree, and carrots yield more when they have the right plant combination. Oh, really? I didn't notice. Companion preference is different for each individual plant and cannot be predicted. Unfortunately, the companion preference of the plant under the drone might be using get companion. It returns a tuple where the first elements can be measured get companion. It returns tuple where the first element is the type of plant. Okay, the thing behind is a little bit distracting. We're going to pause that. Okay, nice. We have a massive pumpkin. Just wanted to collect it. I guess we're not doing that. Okay, fudge. We lost our thing. All right, pumpkin farming. Folks, I think there's something we could do here. There's a small issue with our pumpkin farm here. Give me pumpkin! I'll give you pumpkin XR. All good. All right, plant carrot. Here, the two scripts here work hand in hand. On one hand, we have the the plant carrot, which is doing the whole plant the pumpkin thing. But I think as well, if entities is not equal to entities pumpkin, plant entities pumpkin. But we also defined a healthy pumpkin count if that pumpkin, and then we reset it to 0. But I think as well, I think if it is not equal to entities.pumpkin, so the issue here we have is, folks, that sometimes that pumpkin goes before, right? That pumpkin goes first. So the thing is, sometimes a plot of land will not have any pumpkins at all, and yet the counter will keep on counting. And I think that's an issue, because, so let me explain first and foremost, what are we trying to do with this? I'm going to read your comment in a second, Scott. So what do we want to do? We want to plant pumpkin is dead pumpkin. So this function is basically counting how many dead pumpkins we've seen. And since it goes sequentially and all the different things, if it meets 36 healthy pumpkins in a row, then it means that we should have a massive pumpkin. Because we want a massive pumpkin, because massive pumpkins are good for yields. Or just optimal. Massive pumpkins are just better. So get entity type, we should change from the definition of is dead pumpkin, we should change it to, here instead of saying entities dead pumpkin, we should also trigger it if it's not anything like, if it's just regular dirt, we should also treat it like that. So I would rather say if entities is not equal to this, so it also includes anything that it's not. So if it's not something, it's not entities pumpkin, then healthy pumpkin count goes to 0. Does that make sense? Hopefully it does. Maybe it will increase our odds a bit of, because pumpkins you see here have a little bit of odds of being bad. So maybe it's something relevant. All right, cool. So plant from carrots, import plant pumpkin. All right, let's see it. Should have it optimized a bit more. World size, get world size, then healthy pumpkin count. Ooh, I love that idea. All right, let's do it. Jim the Dandy. Good one. All right, let's see if we can get a full harvest. Well, the thing is, get world size is good. It's just that, all right. Oof, okay, cool. Now it should, collect it a bit early. It should have done it here. 44. Did we increase our... No, we didn't. Why do we have 44? 44 is a little too low, no? Because here 1, 2, 3, 4, 5, 6, 7, 8. 8 times 8 is 64. Yeah, you're right. So 44 is just not enough. I don't know why I thought that. All right. Ooh, fat pumpkin. All right, so we have to do it at 64. You're right. Let's pause this. So pumpkin farming, we're going to change. You're right. Get world size is a little bit more scalable. But this is for the whole world. I agree that it should be a bit higher, at least 64. But at the same time, I don't want to have it a massive pumpkin. I don't want the whole pumpkin to take the whole space. So we're going to keep it at that for now. And then we'll adjust it later, Jim the Dandy. But it's a good point to have it more get world size and stuff like this. We'll keep it in mind. All right, Scott, since you bought more ground in your harvest function, I think you need to upgrade your healthy counter. Exactly. Yep. Scott's got it all. And then Jim the Dandy improved by making it scalable. All right, so let's keep on farming. I think we can get a bigger world kind of soon. All right, this and this, because we need how many? We need 8K. The thing is, the world is not really an issue here. We can, I don't know if we even want to get this, because we already have max pumpkin. Polyculture. Okay, let's see what polyculture does. Okay, increase the yield and multiply polyculture by 1,000 to 2,000. Okay, so let's read a bit more about polyculture. So different things get when plots are grown together, adjacent to each other. they tend to be a bit more. They tend to be a bit more productive. So that's the idea here. Fun story. I worked in farming a little bit, and it turns out for coffee, I was in when I did this trip on the top right there, the returning from war, from the cyber war, from the stream wars. You want to have coffee beans below, and then a banana tree, banana or avocado tree on top. So I hope, folks, you'll think about me if you want to start a coffee farm. Get banana and avocado trees to make sure that. Oh no, it farmed. To make sure that that you get maximum yields. All right. You may have already noticed some things. All right. Fortunately, the companion preference of the plant under the drone can be used to get companion. It returns a tuple where the first element is the type of plant it wants as a combination, and then the second element is the position where it wants its companion. So plant type X, Y. Oh, get companion. Okay. Wait. Plant type X, Y, get companion. I don't get it. Is there a way to just execute this to test it out? Yeah, no. What is this here? Minus pumpkins. I think we're good. So what if we type here, just we want to test out the thing. Print get companion. Do we just do that? Hold on. This we can close. This we can put on the top right, and then we can see here this. None. Why is it printing none? Get companion because is it because it's empty? Print get companion. Oh, wonderful. Jim the Dandy. We think alike. Works on grass, trees, bush, and carrot. All right, so let's do carrot, plant carrot, pumpkin farming, carrot, and tree setup. All right, you're gonna execute this. Entities grass 1-3. Entities dot grass. Oh, so they like being next to grass. Okay. This increased their yield. All right, so you keep going. All right, it starts replanting. All right, we're gonna pause. We're gonna pause, and once you are next to a tree, we're gonna ask that same question. Oh no. Okay, print this. No. No, fine. All right, we have to go one more. All right, plant a carrot. Now plant a tree. Oh, no, it harvested. Planted a tree. And now I need you to print this. No. What are you doing? Is that a bug? It wants grass at 1-3. Oh, I see. Oh, wow. Entities grass 5-4. Where's 5-4? There's no way. 5-4. That's super far away. Entities grass 5-4. Wait, does that make any sense? For example, if you plant a bush and then call get companion, it will return something like entities carrot 5-3-5. This means that this bush would like to have carrots at the position 3-5. So you want carrots at the position 3-5 and doesn't harvest the bush and then harvest the bush, it will yield more wood. Okay. The growth stage of the carrot doesn't matter. Oh yeah? A plant combination preference can be either entities.grass, entities.bush, entities.tree, or entities.carrot. Okay, each plant chooses this randomly, but it will always choose a different plant than itself. The position can be any position within 3 moves of the plant except the position of the plant itself. Okay, and maybe they're gonna overlap too. Just plant the thing you're gonna harvest in the center of a 7x7 and then plant the companion, then return to the center and harvest. Just plant the thing you're gonna harvest in the center of a 7x7, then plant the companion, then return to the center and harvest. So just plant the thing you're gonna harvest in the center of the 7x7, okay? And then plant the companion, then return to the center and harvest. So to the plant, you mean, or I'm not sure. I'm not sure what I get if I get what you mean, Jim the Dandy. So here you can companion entities that grasp 5-4. Okay. So let's move one more along, maybe. Can you move again? Oh no, it has to start again. So here we have a pumpkin. If we print this here, all right, there we go. All right, planted. Here, let's get this. No. What the fuck? Pumpkin farming. Plant. Cool. I want you to read this to me. No. I want you to read this to me. So let's stop this. Expand. Print this. No, it moved. I want you to get printing. None. Okay, so pumpkins don't necessarily have any in general. All right. The bonus is good. You don't need the field. You'll probably make a movement utilities file and make a move to XY function to make things easier. Movement utilities. I like that. So we should make a movement function. Can we do, maybe there's a move already. Move to a certain move to a certain coordinate, to certain coordinates, no? Movement utilities and make a make to XY function to make things faster. Okay. So that works. I kind of want to make pumpkins a bit more optimized, just for fun. Look, there's something that's going on, and I think, Jim, this is going to help us for Git Companion, to understand a bit more about the positioning thing. The thing that's very inefficient in our pumpkin farming is that whenever we have a dead pumpkin, it's going through all the healthy ones all the time. Maybe we can have the robot come back, understand which ones are healthy and which ones are not, and then take care of them individually. Instead of having to go, and then we'll know exactly when everything works okay and when we need to replant, right? Does that make sense? The bonus is good. You don't need to field. Okay, so we read this already. Good, folks. Let's do this. We'll improve a bit of pumpkin farming, and then I think it's going to help us pull some of that code to then get the companions and get things right. So right now we're still going to optimize the pumpkins, and then we'll move to other things afterwards. Make sense? Nice. I hope it does. Cool. You having fun still, XR? I noticed you haven't been as active as usual. Is Python not your thing as much? Scripting in general? So plant carrots and plant. Okay, the carrot and tree setup is not something we're interested in right now. We are interested in plant carrot. All right, some crop plant tree. Okay, so this was to plant trees. We wanted every other one. The thing is, we're gonna need to prioritize a bit sometimes, just what we want. I'm here not as confident in the actual Python skills. but I'm being honest, and I'm working on a few things in the background too. Yeah, nice. I get it. Nice, nice. Oh, what are you up to? Now that you have the certification, are you working on C# as you were before? All right. So we're gonna improve plant farming. XR video GitHub void alter playbook. All right, let's have a look. Let me open. I'll share. Work on that. Okay, let's see. Void Walker playbook. I'm just gonna looking at XR's link. Ooh, I don't see anything yet. I guess you're working on it. Void Walker. What is a Void Walker? Void Walker. I'm gonna search it on the internet too. Void Walker. Ooh, an unmissable. Is that a video game thing? An unmissable new romantasy series from the Instant Sunday Times bestseller, Beast of the Void. Nice. Would it be so bad to be devoured? Oh my god. Seems complicated. Alright, close this because there is nothing there. That's the name of my VM host, lol. Ah, okay. That's a nice name, I like it. That's a nice name. Void Walker. Alright, cool. So, in the meantime, folks, while XR develops a VM, we are gonna farm pumpkins. We're gonna farm pumpkins and we're gonna make it more optimized. Alright, so we said that we wanted the robots to understand which ones were still bad. So we're gonna, is dead pumpkin, I think we're gonna start a new function. We're gonna start def is dead pumpkin 2. Makes sense, no? And we're going to define it as follows. We're going to create an array. We're going to create an array that is, how do you declare an array? Is it like this? Dead pumpkin ground. You do it like this, no? Equal this. So if get entity type is equal to 1, 2 is equal to, oh, there's if of course the remedy is not attributed to that. Ah, nice. Okay. If get entity type is equal to entities.pumpkin that dead pumpkin. Exactly. You're gonna add, how do I get the place of something? A square. Is that possible? Operators, while loop, import loops. Polyculture, pumpkin, census, speed, flowers, trees. We can get move. Okay, move east, move north. Okay. Move down. Returns true if the drone has moved, false otherwise. Takes 200 tricks to execute if the drone has moved 1 tick otherwise. I'm not sure what the ticks mean. Alright, function grass, loop, operators plant, harvest, measure, move, number of items. Ooh, interesting. Number unlock sure. Yes, get position X, get position Y. Oh, perfect. Genius. I didn't think about that. Thank you very much. Then we create a new variable, I think, called coordinates. Coordinates. How can we append it? How do we append something in Python? Appending is with a dot? No, it's with a plus. I think we might be append, no? No, I don't think so. All right, so let's do dead pumpkin. Ground. Plus equal, maybe? No, plus equal, maybe. That's my phone on this one. Do 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 do. Do 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 do. List the instructions. Lists in the instructions. Then pumpkin dot append. Okay, I think. Let's try it. That's a good one. Thank you for that, Jim. That pumpkin ground dot append. That's what I thought too. Ah, there we go. Dot append. See, the color looks really good. Coordinates. Dot append. Okay, maybe we can just do. Okay, we need a bit more space here, please. Plant crop. Now let's define something. Coordinates. Coordinates is equal to get position X, get position Y. Does that make sense? Does that make sense? I don't know if it makes sense. I think the naming might be wrong. Because here we have a list. I think we need to make it in between parentheses. Print it after append and find out. Okay. Yeah, I agree. I think we're going to do quick print. Quick print. Dead pumpkin ground. Okay. Dead pumpkin. Oh, pumpkin ground. All right, pumpkin ground. All right, cool. Dead pumpkin ground. Okay, so that works. And if we find one, we're going to do that. So is dead pumpkin, we're going to transform it from is dead pumpkin 2 here to is dead pumpkin. This way we won't have to change all the numbers in here. Plant pumpkins. And then it starts, the first thing it does is it starts is dead pumpkin. So we should see quite a lot of printing here. All right, let's do this. Pumpkin farming. The module has a syntax error. Dot append. This is not a valid statement. Check lists in the instructions. Okay. Lists. Print range. LMNOP. Should be for that. Built-in function. Entities. Grassland. Grounds. List. All right, where's lists? Where's lists? If loop, loading backups. Where's lists? Is that what we meant here? Listen, click on the unlocks, I guess. Oh yeah, we didn't unlock it yet. Import. Oh wow, we didn't buy it yet. Damn, you're right. All right, list 1, 2, 3. Okay, 1 true. Okay, maybe we still need to develop array or something. Dictionaries. Yeah, we definitely need that too. Okay, wow, this is exactly what we want. X, Y, get position X, Y. Here's another one that maps the drone's position to the entity. So xy is equal to git position x, git position y. Wow. Look at this, folks. It basically gives us the answer a bit here, huh? X, Y. Okay, I think we can just save it in a dictionary. Get entity type. So here you can have a list of everything. In the dictionary, you can have a list of what there is. The thing here, though, is that for us, should we make a dictionary then? I think we should make a dictionary. Yeah, a good call on the unlock side, Jim. All right, list, I think we can delete. All right, pumpkin that append. Okay, we don't want to do that just yet. That pumpkin ground. How about okay, this is still important. That append, okay, that append is a real thing now. Okay, it works. We've unlocked it. That append. Or should we make it a list? I'm not sure if we should make it a list or a dictionary, actually. All right, lists. Entity list. All right, tree, carrots, plant list 1. Okay. List 1, okay. I think you could just do a list of the X, Y coordinates to check. Extra info would be extra info. No, yeah, that's true. Let's do a list. You're right, let's go. All right, is dead pumpkin ground this append quick print dead? Okay, let's see. Let's do it. Now there shouldn't be any errors. Okay, maybe there is. Dot append. You still don't like the dot append, really? Dead pumpkin ground append element. Yeah, right. Dead pumpkin. Yeah, I didn't mention anything after the append. I think you have to specify what you are appending. Exactly. Yeah. Append coordinates. Nates. All right, let's see it. All right, I have to maybe put in between parentheses. Appending. I don't know if I think you're trolling me here. So we're not getting the dead pumpkins until we get back. It doesn't. Where's our return thingy? Where's our script thingy? Okay, this is for polyculture. I think we can do that later. This is for lists. I think we need it. Dictionaries, we need it. Where can we get our oh, I think it's in the let's go to print. And then you can see output. All right. Where we can go to print. Right click for more information. Debug, okay. Print the output page. There we go. Oh, so it says get position X, get position Y. So it doesn't actually get position. It just appends. It just appends the stuff. We're screwed. All right, so it just appends stuff without doing it. So we need to, okay, but the good thing, no, wait, does it? You forgot the parenthesis. Right. Thank you, good Sir Jim. Oh, most definitely, lol. Alright, plant carrot, pumpkin farming. Let's see. Alright, parentheses. So All right, for the output, see output.txt, truncanated output. Let's see. All right. Ooh, nice. So we see it, but I don't think it's appending. 4.2, 4.6. Is it still appending? 7.3. Is there another one? 3.0? All right. Pause. So it's spotted. Okay, it spotted all of these. That's a lot, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's 24 out of 64. That's a lot, I think, because the expectation would be 12, I think. Maybe it counts them twice. Because it's a 20% chance. And 20% of 64 is about 12. I think it's exactly 12. Jeez. All right, so we got a lot of dead pumpkins. And we got them replaced. That's really good. I don't know how we got them replaced. Because we kept on planting, I think. We kept on planting pumpkins. All right, so this. Truncanated output. So I'm not sure how well it's appending. Quick print dead pumpkin ground. So I'm thinking a bit here, folks. When we find a pumpkin, it's going to replant, I think, regardless what happens. It's going to replant because our plant underscore pumpkins, what does this function do? Plant underscore pumpkins is gonna, if it's not equal to pumpkins, it's just gonna start planting. So that's really good. Now we need to influence it afterwards, after it runs. We need to influence it after it runs the second time, because the first time it's going to plant, the second time it's going to map out the whole thing. It's going to say which ones are healthy and which ones are not healthy. Does that make sense? And the ones that are not healthy are going to be replanted. So we need to come back to these and then make sure that they're healthy, right? And if they're not, we replant them. Probably with water, actually. Probably with water, because then it's going to make it faster. So how do we do this? We have a list here, but it doesn't seem to append very well. No? Output.txt. I'm going to check this out. Yeah, same thing. So, these are all the things we need to come back on. So, after we've gone a second round, after we've done this once, right, for one board, we need to start taking care of those. So I think we still need the 64 here. Why? Because we need to go a complete run, at least 2 complete runs, right? One for planting and one for checking that the plants are healthy. And then after that, we can check on the thing. Every time you run the function, you are emptying the list when you define it. We want to stick the list outside the function. Yeah, I think this is actually what's happening, actually. We exit the loop, and then this is no longer this. So you think we should do it like this? Dead pumpkin ground, like this? Will this solve our issue? Okay, so it's going to plant. Then when we get back, it should hopefully give the truncanated output here with the full list. Yes, yes. Jimmy. Yes. Attaboy. Well done. Here we have quite a few, actually. 7-1. All right, cool. So, folks, this is amazing. So, do you agree with me that we should do 2 times 64 to determine whether it should go once to plant and then one more time to make sure that everything is okay? No, excuse me. One time to plant, second time to check on all the pumpkins, see which ones are bad, replant them, hopefully, most likely with water, and then after that, it's gonna go only to the ones that are unhealthy. Every time you run the function, you are emptying. Okay, so you already told this, Jim. That was really useful. All right, so plant carrot. So folks, this is really useful stuff. This is where we have all the dead things. So I think once square 70. Okay, so once the robot has worked 64 times, we can make another function. Squares worked. Maybe we can put pumpkins square worked. How about this? Def pumpkin square worked. Since last harvest, right? All right, we're gonna need to put a harvest afterwards. So, yeah. Okay. I'm thinking a lot of things here, folks, and it's hard to put it all into words. The fun part of this game isn't very open, is that it is very open-ended. There aren't really right or wrong answers where you can make. Yeah. It's just different ways of making the same thing. I'm pretty sure that you found that out too, Jim. Right now, when you're watching the stream, you're like, oh, I did this different, or oh, he's doing it different, or something like this. So here I'm doing is pumpkin square worked. We're gonna do, it's gonna count how many squares we worked on. So I think this one we can delete. We're no longer going to work with it. I think we can delete. All right. Maybe we can just put it up so that we don't see it anymore. It's distracting. All right, there we go. So we do this. Pumpkin ground this. Oh no, we still need this, no? Global MTT. Which one is it calling? Is that pumpkin? All right, it's this one. Def plant pumpkin is the one we're interested in. If ground type is equal till, if get entity type is equal to entities, that pumpkin, you plant a pumpkin. Is not equal to entities on pumpkin, you plant pumpkin. Exactly. All right. That's good. That is good. If get entities type is equal to entities, that pumpkin, you get the position and you save it. So now we know that it's working. Then we're going to need to def pumpkin square worked. So this is what we're going to do. You are going to be a count measure for how many times we've moved or we've done something. Plant pumpkins. For how many actions we've done. For how many squares we worked on. So another way of saying how many squares we worked on is saying how many times have we moved. Right? And I see that every time we move, we plant pumpkin. We run the function plant pumpkins. So I think we should also run here. You see here, every time we move, while plant pumpkins, Except here, actually. Here, we're true. We plant, we move. We plant, we move. We plant, we move. We plant, we move. We plant. So here there's one more plant thingy. There's one more plant being run. So what does that mean? Are we planting twice with this function? All right, there's an error here. Yeah. All right, let's do control X of this. All right, let's see it run for a little bit. All right, there's a move east. You see here, move east. Plant pumpkin. Get grounds type is not equal to soil, so you till. Get entities type pumpkin, so you plant pumpkin. And then you go while true, plant pumpkins. So is that pumpkin? So it's running it twice. We do not need this one. We do not need this one. It's a bit of waste of code. Nice. Cool. I got the page to display some of the things I wanted to do, lol. It is how I am going to make my notes more publicly accountable. That makes sense. Ooh, I like it. I'm going to hold you accountable. If notes are not good, I'm going to put a while loop. While notes not good, complain to XR. I'm not proud of this joke. I've been working on Python too much this week. Forgive me, XR. All right, move east. Move east. So we got rid of one thing that we didn't need. That's really good. So every time we run plant pumpkin, we just moved after. So we can just add here def plant pumpkins. We can also add we got rid of it. So we can do pumpkin square worked. And pekin square worked. You run this too. And so we're going to introduce a thingy, just a variable that is going to say is equal to 0 at the beginning. Pumpkin square worked. So we have the variable and the function to it. Go back here is equal to 0. And then the pumpkin score. If this runs, then pumpkin score worked plus equal 1. Simple. Word plus equal 1. Return 0. Yeah. While notes equal to trash, return 0. The insult. Pumpkin square worked is equal to plus 1. Okay, so when it reached 64, so we're going to need to say, or we're going to put it here, I think. Is that pumpkin? I'm down to delete this. And we're going to start over. Now, I think we should define this into another function. Folks, we love functions here. This is a function stream. All we do is function. Def. So folks, if there's anyone here really confused about what we're doing because they haven't been here in the past 2 days, we are playing a game called The Farmer Was Replaced. It's an automation game where you have to plant stuff. And it's fun. I promise. We have to plant things, and it's fun, and you do it in Python code. So right now we are defining different functions that are going to allow us to plant pumpkins. If there's any questions about why we're planting, or we understand we're planting pumpkins because we need pumpkins. And here the thing is, we want to make the pumpkin as big as possible. And to make the pumpkin as big as possible, we need to make sure that none of them are dead and that they unite together. Because when we have all of them in a nice little square, a big fat pumpkin, like this here, you see there's a big fat pumpkin, but it can get to the whole square, then this is when we get all that juicy pumpkin, and their yields are enormous. So we're programming Python to go only to the squares where there's dead pumpkins and then replace them. And then once it sees that it's healthy, it deletes it from the array, and then it never comes back again until it starts another loop. Makes sense? Good. Any questions or complaints, please send them in the chat. I love complaints. If you have any complaints whatsoever, please send it in the chat. Not necessarily about me, but maybe about your neighbor, about your partner. Oh, wait. I'm afraid that my partner might be listening and might start complaining about me on the chat. I'm listening in. See if there's a reaction. I don't think so. Don't think she's watching. Okay, cool. Cool story, bro. More hacking, please. Random shoe flies towards the head. It just like spawns from nowhere. All right, define. All right, so we're gonna need a new one. Plant pumpkins. What are we gonna call this function? We have is that pumpkin. We have pumpkin square worked, and here we're gonna do actual. How about actual work? Actual pumpkin can work. Drup. Def actual pumpkin work. And you're gonna take in. All right, need a colon. Do I need to here put in coordinates? Do I need to? I think I need to take this. No. Dead pumpkin ground. Well, I think. Do I need this? I was gonna say, do I need to put things in there? But I don't think I do. Actual pumpkin work. I don't think I need to put the dead pumpkin ground in here because it's already a global variable. So if dead pumpkin ground, if pumpkin square worked is under 64, right? No, 64 times 2, 128. 128. Does that make sense? We need to be precise on this one. Or do we? 64 square is equal to 128. When it reaches 128, it's not going to do it anymore. 129, I think. You're going to do what we usually do, which is this. Oh no, I lost my functions. Shoot. Okay. So we're going to, this we need to say if the ground is not right, you're going to do it. If ground is not equal to grounds.soil, get ground type does not equal to grounds.soil, grounds.soil. Oh, no. Maybe there's a big, I think there's a big one here. Grounds.soil. Soil, then you till. And then here you plant if get ground type, no, not ground type, entity type is not equal to healthy pumpkin, entities.pumpkin, entities.pumpkin, then what do? Is it the pass after you filled the list? Is it the pass after you filled the list? Is this the pass after you fill the list? So this is the regular stuff we used to do before. This is just planting at the beginning. And if it's not a pumpkin, then you freaking plant. You freaking plant. Then you plant. If the entity is not a pumpkin, then you plant it, right? Plant. Oh, how do you plant something? Plant tree, pass, plant, print, name and break. No, you plant. How do we plant something? Grounds at soil. Let's see, entities, plant entities, carrot. Entities dot, no, not carrots, pumpkin. This will be confusing. All right, plant entities, pumpkin, makes sense. And then afterwards, if it is over, pumpkin square worked is over 129, we start using the is that pumpkin function. All right, so for you, we can do an else. We can do an else. And then here we start using the function that we defined here. Dead pumpkin ground append coordinates. So here we should go, we should move. Oh, the thing is here I have move north and move south and stuff like this. So that's gonna fuck it up a bit. Wow, we're gonna have to do a movement function. Doof. Doof, 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 doof. This is a challenging one. We're just optimizing a little bit. We haven't even gotten power yet. Folks, this is interesting. And we're optimizing pumpkins a little bit, by the way. It's not like a huge optimization. I mean, it's probably gonna make things maybe 40% faster. I think it's gonna be quite fast actually. But we're learning how to make it work. Look, we learned how to do the coordinates thingy, so we're moving forward. All right. The thing is here we're doing plant pumpkins else, and here we're gonna need to affect the movement of the robot towards these things. So move east. So this works. Maybe we can do it. How about we do it there? No, I don't know. Movement, it's really easy when it's maybe we can do it here in this code. So when pumpkin square worked is over this, we stop doing this and then we move to something else. Maybe we could do it here, this. Does that make sense, folks? I think I'm not making too much sense. This is going to be used for the first 129. So that's 128, which is 64. Oh my God. 64 is the size number of squares we have. 121 is 64 times 2 plus 1. I don't think we need it actually. Well, it's so that it doesn't stop at 128. So when we reach this level, we run this. After that, we should exit this. And then we should start running towards the dead pumpkins. I think it makes sense. Hopefully it makes sense for you too. Move east. So, how do we exit this? How do we exit this whole thing? Well, we can do another while loop here. The nested while loop. While pumpkin square worked is below 129. Is below 129. Then you do all this. All right. And then after the exits a while loop, I would like you to start moving towards the different entities. Does that make sense? Start moving. Can I do move? I want to check out how to do move. All right, move, do lists. There's a move thingy here. M-O-V-E, M-O-V-E, M-O-V-E. There we go. Oh, okay, that doesn't do that. Can I tell it to move to a certain position? Set string till use items range. Get position, do a flip, dictionary, get companion, change hat, can harvest, get entity type. Len counts the number of things. Okay. All right. So how do we... What do we want to do even? We want to move to someplace. How can I get to move to someplace? Do I need to get a new move function? I could do that, huh? Like, what, do we need to do that? You will need to code a move to XY function. Ooh la 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 la. I agree. That's a challenging one. Woof. Woof. All right, else. Okay. Def actual pumpkin work. So we don't need to have that actually. We don't need to have that because this is already in the main here. Here we can do this. Maybe this one more time. It's not bad. Just make a new file and call it movement or something. Yeah, maybe I need a new file here. You're right. It's starting to be a lot on one file. All right. So plant carrot. Oh my god, this is so inaccurate nowadays. We're doing pumpkin. Most of it is pumpkin. Ah, we moved it here. Wait, is healthy pumpkin count gonna work? Healthy pumpkin count. No, we're done with healthy pumpkin count, no? Dead pumpkin is dead pumpkin. Yeah, we're done with healthy pumpkin count. We can delete this. Cool, we can create a new text and this is gonna be the movement. Movement. All right, so we're gonna code here. Jim the Dandy is right. We need to have a function that moves to different places. Does that make sense? So apparently it's not that bad. Okay, so we're gonna put this there. Movement. So it takes movement. Let's do def movement. Def movement. And it takes in X, Y. And there should not be a space here. Move X, Y. And X should be called movement or something. X should be And okay, so depth movement. So it should look at our current position, right? So we're going to define current position. Pos is equal to get pos all right, let's do it by coordinate. I don't care. It's a bit childish, but get pos. Oh, no, whatever. No, we'll do it the proper way. We'll do it the proper way. Fine. I was gonna do it by two variables, x, y, and stuff, but it's okay. So let's do an actual get. All right. Current pos is gonna be get pos x parentheses. We've learned our lesson. Get pos y double parenthesis. Lol. I too had flashbacks to middle school. You are correct, not childish. Yeah. yeah. I mean, it is easier, but I mean now we're grown ups. I mean, also we'll save some energy later when we'll run this a lot. Because every line of code that we make is making it longer, so and we have to learn how to do this as well, right? So okay, def xy. So we're gonna do differential is equal to current position minus xy. How about this? Current pos. Let's just do differential. Differential is equal to get position x, get position y. This is going to be minus x minus y. It works, no? So let's say we are currently in square 1, 1. And we need to go to square 2, 2. This is gonna be positive, right? So for I in range is it range? For I in range differential 1. Oh my god, I'm going ballistic here. Full brain power. Differential 1. You're gonna this is not a range. For one in len? No. Maybe I think it's range. For one I in range, you're gonna how do we do this movement function? So for I in range differential 1. So what I'm thinking about here, folks, what I'm trying to do is in differential 1, so this position, get position x minus x. So this is basically how much we need to travel on x. But the thing is, this might be negative. Do we signal x is negative here? Do we say, hey, this is negative? Does that make sense? Do we say, hey, that's negative? We can do if negative, then you transform it to positive, and then you say negative, positive, okay? And that could work. That could work. My god, it's complicated. So differential, okay. So I kind of want to test this out already. Let's do it. Differential get position. So we'll save this for later. We'll comment it out. We could have done this earlier, actually. Whenever we wanted to delete something, we could have commented it out. If you want, I can show you what I did. Oh, yeah. Actually, really useful. Jim the Dandy, can we do it after, though? And we can compare how we did things. You're on Discord, no? Ah, okay. You can show me this. I don't know if I want to look just yet. I don't know if I want to look just yet. Look, I'll copy the... well, we'll come back to the comment before the stream is over. Before the stream is over, and feel free to remind me if I somehow forget, but I think I won't. So we'll have a look. Differential, get position x minus x. Because I think it's super important. I think it's super good practice. Differential is equal to get position x minus x. Get position y minus y. So it's all good. You just look so stressed. Stressed? No. Maybe not stressed, but very focused. Get position x. There's so many options of what we can do here for doing movement. So I want to figure out what differential. How about def movement? Okay, so let's define x and y here. Def, so x is equal to 1, y is equal to 1. How about we do that? And then we print here. Print the differential. You good, sir. Let's see here. All right, let's delete a few things here. I think it's looking a little weird. Is there an error here? That's okay. Why is it not printing? Should we do quick print? Such a well done game, folks. All right, def movement. Oh, we didn't trigger the function. All right, let's see it. 1 minus 1, so that works. That works, right? 1 minus 1. Yep. Okay. Woo. And now we need to do a for, I think. For loop. How about we do prick differential 1? How is this going to work? Prints minus 1. Wow, we got it right. Good, folks. Good, Gucci. All right, for I in range differential 1. Okay. I like this. Oh, how about print range? What will it do to print range? And we need to comment this out again. Huh? Range 0 minus 1. Well, that might do it. For I in range, is that range going to be... Can a range be negative? I think so, no? Let's try it. For I in range. Differential 1. Is the range going to be negative? I don't know. For I in range differential 1, you're going to do... You're going to move towards X. So we just need to move to west or to east. So if it's negative, we should move to the east. If it's negative, we should move to the east. move, or no, we should go move, yeah, move east. How about that? How's that? That's right. For iron range differential 1. Okay. So how about this? If, this is not going to be very efficient, but it's going to work. If differential okay, while differential 1 not equal to 0, not equal to 0, we're going to do the following. If differential 1 over 0, then you need to move west. Does that make sense? Hope it makes sense, folks. Move west. No, east. Right? Because if the get position, so right now our position, our desired position is this one, and our x is actually larger, we're going to need to move to the left. So we're going to move west. So this is get position. Oh, actually, it's the other way around. I think it's west because we want to be closer to there. Oh, Jim the Dandy is helping us out. You need to give a function location to move a la 0, 0, or 0, 2. 2, 2. Yeah. I'm going to do it differently, I think, Jim the Dandy. We're going to see what you did afterwards. But I think we don't need to move to a certain point and then do it. Movement, 2, 2. Yeah, I don't think so. I'm just going to move east if the differential is over 1. I think west, actually. West. Or you're going to see it. I think it's going to make sense to you. Differential is over 1, you're going to move west. If differential... If... Or we can do else. Move... east. I think it's going to make sense. And then we do the same thing here for the y's. Differential 2 is not equal to 0. Here we're going to move west, so we're going to move back to the center, so that's south. At the very bottom, you function these arguments for the math to work and to move to the target location. Okay. South, north. All right, let's see it. Differential 1. Oh, right. Whee! Yeah. Oh, okay. Why is this not... Well, hold on. Differential 1 is not equal to 0. Well, it should be 0. Oh, we didn't. If we move west and then we move differential 1. Oh my god, I misspelled it again. Differential 1 is equal to different 1 minus 1. Minus plus 1. All right, this should work. This two 2, -1. And here, -2, differential 2, -1. -1, okay, now this is +1. I think this should work. Should work. Vamos! Ooh. Differential 1. Differential 1. You don't like it. In movement, okay. Else move east. So you're supposed to move east, apparently. Differential 1. +1. You can't do that? All right, we can do differential. You can't directly do that. The wall function you're going to make will continue moving indefinitely. Well, look, when it reaches 0, differential 1 is equal to 0, then it's gonna do that. And it will eventually reach 0 because we're slowly progressing towards this value here. And when it reaches 0, it ends. So the issue here is maybe we cannot edit the differential 1 is equal to differential 1 plus 1. You can't do that, maybe. Maybe you can do differential is equal to get position. Maybe you can do that. Differential is equal to 1 minus 1. That should work, no? You can't do that. I see. Your function is actively updating the x position while moving towards it. Exactly. It's actively updating the position x. Exactly. I mean, the differential. It's updating the differential, but it for some reason doesn't work. You can't assign a tuple element because tuples are immutable in movement. All right. Differential 1, 1. Okay, so we can't do that apparently. Fine. Then let's do it differently. Differential is equal to well, maybe we can reset. Get position x, get position y. We can just do that. That works too. It's just a bit more math for the computer. Differential is equal to get position x, get position y. Move west, and now we do else tab. This, ooh, it's still dark out. Is it a cloudy day? Why don't we see some light? Noise. All right, get differential is now equal to this. All right, maybe we can just have one per. We can actually control X this. We don't need it there. Boom. And then we do this. Differential is equal to x position x, get position y. No. Minus x. No. Well, actually, yeah, it's good. That's good. That's good. Get position y. We could not have to recalculate this here, but whatever, no? Because here position y wouldn't change every time here. We would just influence position x. All right, folks. If we're right, we're right. Oh. I move east. Okay. We did something wrong. Ay. Okay. So let's run it one by one. Moving x, movement y. Okay. So differential. Get position x. Differential is not equal to 0. So we want to go over there. So it is not. So if differential is over 1, you move west. No, you should move east. Oh, else move east. No, we did it the other way around. Does the same thing but horizontally. If differential should move east, differential get position x, get position y. Okay. Move east. So the differential 1, 2, the number 1. Ooh, okay. So differential is equal to 1, 2, 1, 4, 3, 4. The number 1 would be referenced as the differential 0, 0, and number 2 would be differential 0, 1, and 3 would be differential 1, 0. Wow. So differential. Oh. Differential is the name of the list. Man, I'm struggling to understand this. The number 1 would be referenced as differential 0, 0, and number 2 would be differential 0, 1, and 3 would be differential 1, 0. Differential is the name of the list. This is the list stuff. Oh. 1, 0, okay. Struggling a bit, Jim, to get this. I think we're not far here. It's just move east, differential, while is not equal to 0. Oh, 1, and then oh, that's really cool. Get position y. Oh, we're in the right place here. This should be equal to 0 now. It should be equal to 0. We are in the right place. How about we print here? Quick print. Differential. Okay, so let's see it. Here, 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 here. Here it should be 0. Referential. 0, you see? Here it's 0. Differential is not equal to 0. Yeah, you got Discord. Yeah. Type in exclamation mark Discord. I haven't checked out Discord in a bit. All right, you should be able to see Discord. Can we hide the farmer? Should be able to see Discord, no? All right, delete, remove. I'm not sure why I have to every time get Discord again. Type in exclamation mark Discord. Nice. And let's go. We got memes to look at. Just one sec. XR, the meme lord. We have just sent the code 435 to your phone number. Please enter the... Nice meme, XR. I like it. I wonder if it's hackable. Confirm. Hello, Jim.
Howdy, can you hear me?
Yes.
Okay, so the index thing on the list. So the name of the list is differential. The first number after differential, that's 0, is the tuple.
Okay.
1, 2.
Tuple is basically, I'm just gonna share my farmer screen again. There we go. So tuple means is a number in a series. Is that it?
The tuple is the XY coordinate. One, like, so your differential 1, that when you only have the one set of brackets, it's referencing both the X and the Y value at the same time.
Oh.
It's trying to pass a tuple on. You want to go into the tuple and you want to get the index of the number in the tuple.
Exactly, yeah.
So you need to put differential bracket 1, bracket 0. Actually, they both be zeros because they're both the first thing in the brackets. So it'd be differential 0 bracket and then another bracket with 0. They both have their own brackets. It's kind of like multiplication.
Ah, okay. Wow. It's not easy, huh?
So you are now saying differential. You're pointing to the x. So differential 0, 0 would be the x value, which you have as 1.
So the first 0 is pointing what, and the second 0 is pointing to what? Why do we have to put 2 zeros?
So you made a list,
Mm-hmm.
and that list has a tuple inside of it, which isn't a single value.
Mm-hmm.
So the first 0 is pointing to the first thing in your list. And then the second 0 is pointing to the first thing in the first thing in your list.
Got it. Oh, nice. And so what if there's a dictionary, right? Because then there could be many things in there. You could have 3 zeros, no?
Yeah.
Would that make
You
sense?
could do that with just the tuples.
Yeah. Okay, makes a lot of sense. Cool. So 0, 0. Let's try to see if it works together. Differential 0, 0 is not equal to 0.
You can just print the 0, 0 if you want to see that it equals 1 or whatever number you want for x.
Yeah, I think here it should equal. Let's make a new one. So differential 0, 0. We can just run this. Print. Well, I don't know if we can do that. Print. We can just make this differential.
Yeah, if you put print differential 0, and then you could put on the next line like print differential 0, 0.
Yeah.
And then you could put print differential 0, 1. You'll see all 3 different things that could be printed out.
Yeah, I'm just going to print one and then we'll print the others. Okay, 0, 0. You cannot index into 0. Oh. What?
You didn't put it in brackets. The differential at the top.
Oh yeah, should be in brackets here?
The differential at the top. So differential equals brackets, parentheses, 0 dot negative 1.
But here it's not in brackets either, no?
See.
Differential
It would need to be.
Okay. 0, print differential 0. What if we don't put it into... Sorry, I'm just going to try without brackets just to see what it looks like. 0.
Oh yeah, go for it.
You see, I don't think we need brackets.
I think the brackets won't work unless you have a list.
I'm not sure. There's a lag here. Oh, okay. Jim the Dandy. The tuple is essentially storing a single location on the 2D array of your farm. The differential is subtracting your position to desired position to determine the best move direction. Yeah, exactly. You got it right. So print differential. I think you got it right, Jim the Dandy. The difference is that if we don't have brackets, we don't need to have it twice. So here you see in my code, there's a lag when I'm not sharing a screen right now. If we put in if differential 1, I think it should be 0 instead. How's the game going? Very good, Raf. We're just gonna solve one quick. It's not a problem. It's just, yeah, I guess it's a problem. If differential 1, yeah, 1 is good here. Differential 0. So I think Jim the Dandy, what we might have done here is get confused between the number 1 thing in the array is actually y, and the number x is, instead of being called 1, is actually 0. Could this be? Zero, 0.
I'll be honest.
Oh, look, it
I'm
worked.
new to Python coding too, which is why I enjoy watching it.
Oh no, there we go. It's bugging out. Yeah, I get it. We're all learning. Quick print differential. So the 0 is good. Apparently there's issues here in the X. No, but you helped a ton because I think the differential 0 here makes sense. Print differential 0.
You've got to make it reference the right number out of your tuple, though.
And it is, I think. Look, quick print. Because here was printing on the robot. And it's printing 0. So when we print out, when we have 0, it's going to show the first number. And when we show 1, it's going to show -1. So it's going to show y. So you were absolutely right that we were doing the wrong number. It's just that in X we were referring to 1, which is wrong because the first number was actually 0. And the second number is 1. So you were absolutely right, Jim. It's just that the double brackets was not necessary. This is what was making us bug out.
Sweet. I'll catch you later, man.
Yeah, catch you later, Jim. Thank you for your help. What a bro. Jim the dandy. Okay, let's go on. No, okay, we're going to go on Discord. I'm going to disconnect here. Great meme XR, by the way. Folks, if you want to join us on Discord, just type in Discord. Nice. But great to have you. Great to have you, Jim, and thank you for these explanations. Sweet. All right. How's the game going, Raf? Oh. Hope we didn't lose anything. No, we didn't. Raf, game is going wonderful. Game is going wonderful, and I like being a chatter. Sorry for the confusion when no, you didn't confuse us. That's the thing, Jim. You didn't confuse us. We solved it together because we figured out that the brackets thing was the issue, and we could have double bracketed this and all, but I think just keeping it to simple brackets is okay, and we understand better now what it is, because if we had I think in a dictionary setting you might want to have 2 zeros, but here we only need 1. I think we only need 1. It's very good. Thank you for your help, Jim. So differential 0, 0. How's the game going? So we are now creating a little function that allows us to move around to the position that we want. So we want x is equal to 3, which is here, and y is equal to 1. So let's do y is equal to 2 as well, so that we have to move on 2 lines. So while differential 0 is not equal to 0, if differential 0 is equal to west, differential grid position x, quick print get differential. Let's see it. All right, it's not working super well. It's staying differential, okay, -3. It should stop when differential 0 is not equal to 0. So yeah, it is never equal to 0, the differential. Why is the differential never equal to 0? Get position x, eventually move west, differential x is quick print differential, so that's 4, 1. Now if move east, then it moves here, then it's -3. Ah, I see what's going on, folks. Ah ha ha. You see what's going on? Is that because here when it's actually opposite, that's why. West. I think they should solve it. West, east. There we go. Look at this. It moved to 3, 2. That's what we wanted. Jim, we did it. Yay! I thought you meant west. A good one, XR. Nice, nice. Yeehaw. All right, let's try something else. Yeehaw. We haven't had Brooke today. Yeehaw. 6. 6, 7. All right, we should do 6, 7 for the memes. For the memes. Oh, look at this beauty. It's moving. All right, now we have to look at Jim's code. Let's see a bit to understand how other people could do it. And then we can finish the pumpkin farming, super optimal pumpkin farming. All right, so this is great. We can delete this. And we can delete this. Cool. So nice. So movement is done. Movement is done. Hay farming is done. Pumpkin farming is in process. And now we're going to look at Jim's code. Let's see it. Let's see how other folks do it. And thanks, Scott, as well for your support. It's been really cool. For you to, it's actually been really cool for you to help us as well on the side. I didn't understand the word tuple. It kind of sounded scary at the beginning. So, folks, I'm going to share Jim the Dandy's code. The thing is, I don't want to share this on just a black screen. It's super white. My background is super white. How can I do this? I can just copy the code and show it to you here. Let's go back to OBS. Open this. Copy that. Control C, and then do a new page and show here Jim Dandy's code. All right. So Jim's code is the following. Oh, nice. It's got labels. That's really useful. All right. Def move to x2, y2. x1 is equal to get position y. Oh, that's really good. That's actually what I wanted to do initially. x1, get position x. y1, get position y. If x minus 1 over 0 for I in range. Absolute, move west. Oh, yeah. That's really good. Range, we wanted to do range at the beginning, remember? Jim. And then absolute is, yeah, the difference between those. Move west. And else if, for I in range, absolute, this, move east. That makes a lot of sense. Else if. Oh. Oh, that's really cool. We did pretty similar work in the end. You just didn't have an array, right? That made it a little bit easier to manage. I think an absolute is a little bit better. Oh, boy, was it fun. I just did the simplest thing I think to think of. That's what every programmer should do. I did the coolest thing because it looked fun. No, that's not what we into. All right. So we're going to stick to our code in case we need to debug it, but this is very useful code as well, folks. You want to delete F2 permanently? Yes. IRL, if there was a wind blew off course, yours would still function. Wind blew it off course. Yours would still function. Yeah. Blew it off course. Yeah, I think both functions work like probably the same way. All right. So, chukachung, move. So you were asking earlier, Raps 7 EXE. How's the game going? It's going good. We got a function now, as you saw, that can make the robot move to anywhere we want it to. So, and that function is called movement, right? Movement XY. So, we're going to do a for loop. For I in range. Okay, actually, while, I'm going to do while loop, I think. While the function, so another thing that we did, Raf 7, I don't think you were there, is, okay, we can delete this too. Yes, quick differential, yes. So we want to pumpkin farming, hay farming, I think it's movement, I think it's carrot and street, no, hay farming. No, this is not this. This is not this. Yes. Dictionaries. Pumpkin farming. Okay. Pumpkin pour movement. Hey, farming. Hey, where's our code? Oh, plant carrot. There we go. So, folks, we made a function that keeps track of which pumpkins are dead. So we have a coordinate. We have dead pumpkin ground coordinates. We have a series. We have a list of squares that need to have dead pumpkins, that need to have dead pumpkins taken care of. Oh Lord, this is complicated. Well, dead pumpkin grounds, this is a function that keeps track of the dead pumpkins. Dead pumpkin ground, actually it's ground, is not equal to, is not empty, is not equal to this, then I want you to go to these. So you movement. Oh, we should import it, no? From, well, import movement. How about this? Import movement. Movement dot movement. Actually, we can do import movement from movement, import movement. Right? This is how we defined it. This way we don't have to do dot, I think. Movement. What a great game again. What a great game. Love it. Movement. XY. Okay, we need to define XY here. XY. So how do we define XY? X is equal to... All right, so let's try to run it. Let's try to run it, and then we'll test it tomorrow because we have to go to work soon. Get to work, corporate slave. X is equal to so we're gonna select the first one in movement. In the dead pumpkin ground, we're gonna select one. Can I do this? Dead pumpkin ground. Dead pumpkin ground. Dead pumpkin ground. 2 1. The game is much better than reading a Python textbook and doing these exercises. I tried that before and it was very boring. Yeah, you told me you bought a massive book, no? You bought a massive book and it was not fun. Yeah, for sure. This game is lovely. Movement, dead pumpkin ground, and then we'll do I. For I in range. Dead pumpkin ground? That's a pretty long one, huh? Dead pumpkin ground. I think this works. Movement, dead pumpkin, I. Does I start at 0? Guess we'll see. So first of all, you move. You move to that place. Then afterwards, you should check if that thing is empty, if that thing is healthy, right? Because there's a possibility that after replanting, it is healthy again. if the thing is healthy, so entities.pumpkin, if, what is it called? Ground type or type? Ground get entity type. This is equal to entities.pumpkin. Then if it's a healthy pumpkin, we don't need to come back. If it's a healthy pumpkin, we good. We can just delete. Delete. Can we delete? Jim Dudini, I try to learn off this thing. Alan Downey, GitHub.io, think Python. The author thinks it's very exciting to take classic novels and use Python to count how many times a word is used in the book. That's kind of fun. I can see how it's fun. I can see how it's fun. Fruits equals apple, banana, cucumber, habanero. Yeah, it's the classic way. I think I learned Python this way. Alan B. Downey. The notebook, chapter 1. Programming is a way of thinking. And you learn different things, I think, as well. I think you're gonna get a little bit of an advantage by having read this kind of thing too, because you get more concept behind it. Yeah, it's not as fun, for sure, but I think you do get some principles that are quite important as well. It's like learning on the job versus learning in university. One is learns how to do it, and the other one is more conceptual and opens your eyes to things you didn't think were possible, or they're I think both practical and academic work are important. Right here we're doing practical, and I think we'll need to do some academic as well. Running why, understanding why. You kind of get both in both, but I think you still did good by buying this book. Delete. How do I delete something? Can I delete something? How do I delete? How can I delete something from an array? I'm going to ask ChatGPT on my phone. And then I'm going to need to get to work. Get to work. So, folks, I'm just going to share with you. When I was young, I worked in entertainment. And entertainment is really like slave work. So we had this joke. It was over 10 years ago. We had this joke with a coworker that we were Chinese workers, kind of being exploited. And every time it was like, oh, get back to work. And we used to kind of make the Chinese accent. It was really fun. So yeah, it kind of stuck to me. This is why I kind of say, get back to work like this. Hopefully you all don't think I'm racist. But yeah, just sharing why I said it like that. All right. So how can I delete a piece of a string? Is it a string? No, it's not a string. It's an array. Or what is it? Of an array, I think. Array in Python. Let's see. Pop goes to the weasel. Yes. I'm not sure what go into the weasel means actually, XR. Go into the weasel. Del array 2. Del array. Oh, okay. No, we don't need to say array. Okay. Del dead pumpkin ground. Del get pumpkin ground. I. But the thing is, folks, if we start doing this, we're going to have an issue. Exactly. Exactly. You and I think the same thing, Scott. I just thought that because if we delete number 1 because it's healthy, then it's going to delete the wrong number. It's going to delete number 4. It's going to... Number 1 is healthy, so it gets deleted. And then afterwards, it... we got it right, you and I. I think we're on the same page. It's a little bit hard to explain, but we'll get there. So for... I'm going to create a new array here. Should be deleted. To delete. We don't have enough arrays here. To delete. There we go, to delete. Delete. We're going to... Okay. To delete. Delete is going to be equal. I think you and I have the same idea here. To delete is going to be an empty array. No, we're going to array or... Yeah, let's do an array. To delete dot append. Does this work? Does that make sense? So we're creating a to delete here so that, because the folks, let me explain the issue here. The issue is that, yeah, I think you got it. But if we have an array of, say, let's say we have 3 elements that need to be deleted. Let's say we have XR, CyberDoctor, and Scott. We have these 3 elements and they come in order. So first it's XR, then it's CyberDoctor, then it's Scott. And if we delete XR because XR is healthy, and then we want to delete, and then CyberDoctor is still, for some reason, is still unhealthy. And then afterwards, Scott is healthy. It's going to try to delete string number 3. And string number 3 does not exist because XR has been deleted. Therefore, there's only 2 people left. So this is why we're adding to delete afterwards to append. And then we're going to delete for I and to delete. For I, it's going to del in to. Is that what you meant, Scott? I think it is, huh? Leaves a hole in that position. I agree. To delete in range. To delete. Oof, do I have food? Oh, I don't have food today. Oh, I have to make my food. I'd rather stay here all day and hang out with you folks. But hey, we need to make a living. Oh, and I'm going home. Oof. I better get going. All right, for to del in range. To delete. All right, this is what we're going to need to work on tomorrow. Del. Well, we're going to need to do it in reverse order. So let's add a comment here so that we can start tomorrow from a good place. We need to remove the right. In C#, the array is not resizable unless you create a new and copy the components. XYZ becomes X null. Oh, that's an interesting feature. I mean, we could also make it null as well. And then we can create a null afterwards, a null figure. If null, then you don't do it anymore. We could also do that. We need to remove the elements from the string starting from the highest point, because the highest point does not delete the order of the previous one. All right, hopefully this is enough instruction for tomorrow's stream. We're going to save. We're going to quit. Then we're going to hope that everything's saved. we're gonna keep that lovely photo of the cyber doctor coming back from the cyber wars. I mean, there's cars in there. Doesn't look as dramatic. Jim the Dandy, thank you, Jim the Dandy. Hey, and thank you to you. You also made great code, and you suggested this whole game. So I think we're gonna do it at least a whole week. Let's see how long we keep doing it. I see that you viewers are interested so far. I know you've stayed up longer than needed when I reach at the end of the stream, lol. I know I've stayed up longer than... Oh. Oopsies. Oopsies, XR. You're in trouble. But yeah, always a pleasure having you, XR. And everyone else, of course. Scott, Jim. Who's not just asking poop pants anymore. Just being a regular chatter, which is lovely. And yeah. Scott, you stayed the whole stream as well. Thank you for being here. All right, so I looked at list of streamers on InfoSec streams. We don't have anyone. I'm not sure. Should we stream raid someone else? I don't know. I don't know if I have time. I don't know. I don't have time to search for anything. Even when I watch usually streams, it's just other people doing cybersecurity. Just more fun. Games can be fun too, but not for me right now. All right, folks, thanks a ton for being here. We had Jim, we had XR, we had Scott, we had a few more people. I think we have some more people. I think it might have been just the three of us today. So yeah, it was just a chill stream, the three of us. So folks, thanks a ton. It's only 2 a.m. Time for bed. Ro, I may be talking, but I'ma be here in the shadows. Lol. Okay. It's okay. We saw you were here. And yeah, thanks for everyone in the shadows. It's all good. Hope you cozy in there. Thanks a ton. And see you tomorrow in 22 hours. Ciao, folks. Take care.